Buying your first 3D printer is mostly an exercise in ignoring the spec sheet, because almost nothing on it predicts whether you will still be printing in 6 months. The machines are all broadly capable now. What separates the one you keep from the one that ends up in a cupboard is how much friction it puts between you and a finished print. So this video is built around 5 things that actually decide that: leveling, the frame, the materials you will really use, the ecosystem, and the money you have not budgeted for yet. Chapter 1: Why the spec sheet misleads you. Printer marketing competes on 3 numbers: build volume, top speed, and maximum hot end temperature. All 3 are close to irrelevant for a first machine. Top speed is quoted as a movement speed the machine can reach, not a speed it can print well at. The quality ceiling is set by cooling, extrusion rate, and rigidity long before the motors run out. Maximum temperature matters only if you print engineering plastics, which almost nobody does in their first year, and which usually need an enclosure and a hardened nozzle anyway. What none of those numbers tell you is how many attempts it takes to get a good first layer, and that is the thing that determines whether printing feels like a hobby or a chore. Chapter 2: Bed leveling, which is the whole game. The first layer decides most prints. If the nozzle is slightly too high, the part lifts off, slightly too low and it digs in, and the surface is a mess. On a manual machine, you set the gap yourself with screws and a piece of paper, and you redo it whenever something shifts. It is fiddly, it is unintuitive, and it is where most beginners quit. Automatic bed leveling replaces that with a probe. The printer touches down at points across the plate, builds a height map, and then follows the shape of your bed while it prints. It does not make the machine better at printing. It removes the single most common reason a beginner's print fails, which is worth more than any spec on the box. If you take one thing from this video, do not buy a printer without automatic leveling. Everything else on the list is a preference. This one is close to a requirement. Chapter 3: The frame and what it costs you. Almost every affordable printer is one of 2 layouts, and the difference shows up in how tall you can print before quality falls away. The common one moves the bed forwards and backwards underneath a fixed gantry. It is cheap, it is simple, and it works well. The catch is that the whole print is being shaken back and forth. That is fine for short parts. On a tall, thin model, the taller it gets, the more it wobbles, and you start seeing ripples and lost detail near the top. The other layout keeps the bed still and moves the head in both directions across the top. Nothing shakes the print, so height costs you much less quality, and it can run faster for the same finish. Those machines usually cost more and often come enclosed, which matters for materials we will get to shortly. Neither is wrong. If you mostly print functional parts and models under about 15 centimeters, the cheaper layout is genuinely fine, and the money is better spent elsewhere. The other frame question is the extruder. If the motor that pushes filament sits directly on the print head, flexible filaments are straightforward. If it sits back on the frame and pushes through a tube, they are a fight. Chapter 4: The materials you will actually print. For at least your first year, this will be PLA with some PETC. That single fact settles several of the decisions people agonize over. PLA is easy, cheap, stiff, and prints without an enclosure. PETC is tougher and handles heat and moisture better, and is the sensible default for functional parts. Both of those are happier in open air than in a sealed box because they want cooling. An enclosure is not helping you print them. Enclosures earn their money on a BS and a SA, which warp and crack unless the air around them stays warm. Those are also the materials that produce fumes you should be ventilating. So an enclosure is not a general upgrade. It is a specific tool for a specific group of materials, and buying one before you need it is money sitting idle. The same logic applies to multi-color systems. They are genuinely impressive, they add real cost, and they waste a surprising amount of filament purging between colors. It is a second-year purchase, not a first. Chapter 5: The ecosystem which nobody checks. Before you buy, search your slicer for that exact model. If there is a ready-made profile, Someone has already done the tuning and your first print will probably work. If there is not, you are setting flow, temperature, retraction and pressure advance from scratch, which is a genuinely interesting hobby and an awful first evening. Check spare parts too. Nozzles, a hot end, a build plate and a belt are all wear items, and on a popular machine they are cheap and available everywhere. On an obscure one, they are a 3-week wait from one seller, and a printer waiting on a part is a printer you stop using. And check that people are still posting about it. An active community means your specific problem has already been solved by somebody, usually with photos. Chapter 6. The money you have not budgeted for. The printer is not the cost. Filament is ongoing, and you will get through more than you expect, mostly on things that did not work. Then there is the kit that turns out to be necessary rather than optional. Spare nozzles, a decent scraper, calipers, and eventually somewhere dry to keep filament. Filament drying is the one that catches people out. Plastic absorbs moisture from the air, and a wet spool prints badly no matter what you do in the slicer. So budget the machine plus roughly a third again for everything around it. A cheaper printer with the supporting kit beats an expensive one on its own. So insist on automatic leveling, match the frame to how tall you actually print, ignore the enclosure until you need a BS, check the slicer profile exists, and budget past the machine itself. Notice how little of that is about the printer being fast, or big, or hot. Those numbers sell machines. They are not what makes you keep using one. The best first printer is a well-supported, boring, mid-range machine with a probe on it, and the money you saved spent on filament and a dry box. If this helped, subscribe to Layer Logic. There are short videos on most of these if you want to go deeper on any one of them.